All right, so today we're going to be talking about graphing general rational functions with higher degree polynomials. Thus far we've been just dealing with like first degree polynomials. We haven't been dealing with anything higher, and so now we're going to start dealing with some that are like second degree polynomials. So again, just to remember that when we have a rational function, I have a polynomial divided by a polynomial. And so if you guys think back to Algebra 1, if you wanted to find the x-intercept for a line, what did you have to do?
Wait on the line.
If I had a line, what do I have to make equal to 0? The y has to be 0, right? So whenever we have an x-intercept, y is equal to 0. So that means that what we're doing is we're finding the real zeros of the numerator. Because all that matters is that if the top is 0, the whole thing is 0, right? Okay. When we want to find the y-intercept, then what do? We make x equal 0, okay? So then you just find out what it is. You just plug in 0, okay? You just plug in 0 for x. Okay, that's the same as it always was all the way back to Algebra 1. It's just now we've got a more complicated expression that we're trying to find the zeros of for the x-intercept. Okay? All right, the vertical asymptote. What have we been doing ever since we started doing this? Which part cannot equal 0? The denominator, right? So because the denominator can't equal 0, the asymptotes are when it is equal to 0. So it's the real zeros of the denominator, or q of x. So we set the bottom equal to 0. And then for the horizontal asymptote, it depends on the degree of the two polynomials. So the first thing you have to do is figure out what your situation is. You need to compare the degrees of the two polynomials. Okay, we're going to compare the degrees of p of x and q of x. So if I have a higher degree on the bottom, it will always be y equals 0 with these type of polynomials. Because as x gets larger, if I have a higher degree on the bottom of the fraction is getting really, really big, and the top of the fraction is staying small, and so it's approaching 0. So it's always going to be y equals 0. If they have the same degree, and we've already done some of these with first degree ones, remember we looked at the leading terms, so we're still going to do that. Look at the leading terms of the polynomial, the leading coefficients. And then the new one that we're not going to do any of them today, but just so you have all your notes in one place. If there's a higher degree on top, we end up with an oblique or slanted asymptote. If it's just 1 degree higher on top. We're not going to get anything more complicated than that. Okay, so first I'm going to do a problem where we have a higher degree on the bottom, right? So this first one, we'll do as a higher degree in the denominator, okay? So we've got 6 over x squared plus 1. We're going to graph it, and we're going to state the domain and range. All right, so before I graph it, I want to find all my intercepts and asymptotes. So to figure out the x-intercept, that means y is 0. And so I set the top equal to 0. Is it possible for 6 to equal 0? It's not possible. So there are no zeros, right? And if there are no zeros, that means there is no x-intercept. And for my y-intercept, I plug in 0 for x. So if x is 0, what does y come out to? Right, we have 6 over 1, so it comes out to 6. So my y-intercept is at 0, 6. I'll go ahead and put that on my graph, since I already know that point now. Then I'm going to figure out my vertical asymptotes. So to do the vertical asymptotes, what have we been doing? Setting which part to 0? The denominator, right. So we'll do that again. If x squared plus 1 is equal to 0, and I subtract 1 from both sides, I get x squared equals negative 1. Are there any real solutions to that? No, only imaginary, right? So since there's no solution, that means that there are no vertical asymptotes. And then finally, let's take a look at my horizontal asymptote. As x goes to infinity, the bottom's going to be huge, top's still going to be 6, so it's y equals 0. Again, anytime you have the higher degree on the bottom, it's going to be y equals 0. So I'll just kind of draw that there over my x-axis. That's my horizontal asymptote. And my vertical asymptote, there isn't one. All right, so now I've got to figure out what it's doing. And the only way to do that is to make myself a table. So I'm going to make a table. And I'll go ahead and plug in -3, -1, 1, and 3. So if I do -3, I end up with 6 over 10. So that's just 0.6. If I do -1, I end up with 6 over 2, which comes out to 3. And then when I put in the positive 1, I still get 6 over 2, because 1 squared is the same as -1 squared. So I get a 3 and I get a 0.6. So we already plotted our y-intercept up here at 0, 6. I'll go ahead and plot the other points that I just found. -3.6, -1, +3, 1, 3, and 3 and 0.6. So then you just do your best approximation of what the graph must look like, using the asymptote to figure out where the curve is going to be approaching. That's what the graph would look like. So the only thing we haven't done yet is domain and range. So is there any limit on my input values? Can I put anything into that? Yeah, I can. There's no limit going left to right. There is nothing I can put in for x that's going to make it 0 on the bottom. So the domain is all real numbers. But the range is a little bit funky because there's actually some limitations on it. Because it's never going below the x-axis, I know that y has to be greater than 0. But there's also a high point, isn't there? So y is less than or equal to the 6 because that point is included. So you can write it like that, or you could also write it as 0 is less than y is less than or equal to 6. Okay, so now I'm going to have you guys graph this one. Before you graph it, though, I want to know the x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. And also, I'll just tell you now, you're going to get some fractions in this one. So it's going to be easier to graph it if you make each of your lines worth 1/3. Basically, have this be 1, 2, 3, like that. And it'll be a little bit easier to graph it, okay? So before you graph it, though, show me what you got for the x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. Okay, so I think most of you were getting this, just to make sure we're all on the same page. The x-intercept, 0, cannot ever be equal to -2, so there is none. So don't write 0, write that there is none, okay? And then the y-intercept, If I make x equal to 0, I get negative 2 over 0 plus 2. So that's just negative 1. So it's 0, negative 1. And then my vertical asymptote, x squared can equal to negative 2. There's no real solution to that, so there's no vertical asymptote. And horizontal, as x gets humongous, I'm going to have getting closer and closer to 0. So y equals 0. Okay, so when you make your table, just go ahead and pick some numbers on either side of the 0 and plot those points. Okay, so when you plot the points, your graph should have ended up looking something like that if you went ahead and made every line worth a third. And so what's my domain going to be? My domain. All real numbers, right? Okay. And then my range, someone started to say it. Y is less than 0, and what else? What's it greater than? Greater than or equal to negative 1. Okay, so again, you can write it that way, or you could write negative 1 is less than or equal to y is less than 0. Okay? Alrighty, so now let's do one where we have the same degree. Okay, now we're going to do them where they have the same degree on the top and the bottom. So we're going to graph y equals 2x squared over x squared minus 9. So before I graph it, I'm going to find my x-intercept, my y-intercept, and my vertical and horizontal asymptotes. So for my x-intercept, that means that y equals 0. So 0 would equal 2x squared. So what does x have to be? X would also have to be 0. So it's at 0, 0. And for my y-intercept, if I plug in a 0 for x, it's going to be 0. So it's the same point, right? So 0, 0 is my x and y-intercept. Then if I look at the denominator cannot be equal to 0. So that means x squared minus 9. If I set that equal to 0, I can figure out my vertical asymptotes. So that means x squared is equal to 9. And so what would x equal? 3 or negative 3, right. So I've got two vertical asymptotes. I've got x equals 3, and I have x equals negative 3. So I'm going to go ahead and draw those on my graph. And then finally my horizontal asymptote, I look at the leading coefficients. So I've got a 2 over a 1, so y equals 2. And that's my horizontal one. So now I've just got to figure out what's happening in between each of those areas. So I'll make myself a table. So on the left side, I'm going to put in a negative 5 and a negative 4 so I can see what's happening there. In the middle, I'll go ahead and put in negative 2 and positive 2. And then on the other side, I'll put in a positive 4 and a positive 5. So plugging those values into the equation, y would equal 2 times negative 5 squared over negative 5 squared minus 9. So that's 50 over 16, which comes out to 3 1/8. And then doing the same thing for all of them. For negative 4, I would get 4 5/7. For negative 2, I get negative 1 3/5. Positive 2, I also get negative 1 3/5. Positive 4, I get 4 5/7. Positive 5, I get 3 1/8. Since all the x's are squared, it ends up being symmetrical. So, all right, so then I just have to plot the points and approximate the curve. So negative 5, 3 1/8 would be about there. Negative 4, 4 5/7. So this side of the curve is doing something like that. And so we're using our asymptotes to figure out, again, the lines that the curves are approaching. Then if I plot the -2, -1 3/5, and +2, -1 3/5. So the center is doing something like this. And then on the other side, plot those points as well. And so that's what my graph will look like. So my domain, it's all real numbers except what? I can't have the positive or -3, right? So it's going to be all real numbers except for plus or minus 3. And then my range, the range is kind of funky on this one. Y is greater than 2, or Y is less than or equal to 0. So there's a gap in the range there. All right, so I'm going to have you guys, I'm not going to worry about graphing right now, but I want you to just practice finding the x-intercept, y-intercept, vertical asymptote, horizontal asymptote for this expression, or for this equation. Y equals -x² + 4 over x² minus 3x minus 4. And because I don't think you guys will have time to graph it, but go ahead and see what you can figure out from this. All right, so to find the x-intercept, that means that y is 0, so that means the top of the fraction has to be 0. So if I solve that, I get 4 equals x², so what does x have to be? Plus or minus 2. So that means it's either 2, 0, and it could be at -2, 0. We have 2 x-intercepts on this one, okay? For the y-intercept, now I plug in 0 for x. So if I plug in 0 for x, I get y equals 0 plus 4 over 0 minus 0 minus 4. That's just 4 over -4, right? Which is -1. So 0, -1 is my y-intercept. Then to get the vertical asymptote, that means that x² minus 3x minus 4 can't equal 0. So I find the zeros and I figure out what my asymptotes are. So how do we factor that?
X minus 4x plus 1.
X minus 4, x plus 1. So that means that my vertical ones are either x equals 4, and the other one would be x equals -1. And then for the horizontal, I look at it as it approaches infinity. So as it goes to infinity, my leading coefficient on top is -1. My leading coefficient on the bottom is +1. And that's just -1. Okay? All right, questions? Okay, that's it for today.